Okay, so now that I've collected my data, I now have it sitting as a bunch of JPEG files labeled with the as the same as the angle on my Raspberry Pi. So the next step would be to take the files from my Raspberry Pi and put them onto my laptop so I can process them in PyCharm. I did that simply using a USB. So I took the files and I placed them into my PyCharm folder, as you can see over here. And these are just all of the images that I used. And I'm running this script in Python, which will take the images, apply an HSV mask, and create a 3D point data that we can then use to create our 3D point cloud. So a couple things that we've had to do with this mask. I had to define the HSV mask, which I used by using the color picker on one of the old photos, or one of the photos from testing. I also had to use these two parameters, which were defined during a previous homework, to calibrate my LiDAR. And finally, I defined that the pictures were all going to be in the folder called test, where I would keep all the images that I collected, and I'll have it write to a text document that I'm calling test results. So I run this, and I got a 3D point cloud here. However, it's a little difficult to run in PyCharm. So instead, I took the text document and copied it into my MATLAB directory, and decided to run a script in MATLAB, which simply all it does is take the data and plot it in a 3D point cloud. And once we do that, we get this. So you can see here, here, and finally here is probably the better 3D point cloud. So as you can see, you can clearly see the wall in the back where it's all flat. You can see the outlines of where my laundry bag is. You can clearly see that it is rectangular in nature, a little round, which is true because it's a soft bag. You can see the depth of the bag compared to the wall, and you can see how it is off the ground. I think this came out pretty well. You can see the definite shape, but it probably helped that it was a simple shape. Anyway, that's the data I collected for testing my LiDAR system at home.